For slope-intercept form, then we are looking at functions written in that form, y equals mx plus b, where m is the slope and b is the coordinate there of our intercept. That is our y-intercept in this case, where we're going to talk about how we can use this, but before I get to that, I do want to mention one other form that doesn't get as much play for, I think, good reason, which is called the general form, ax plus by plus c equals 0 for a line. That is a nice sort of consistency with things like the general form of a polynomial, but it's not actually that useful for any sort of application or any sort of understanding of how lines work. So usually when you get something like that, it's just presented as an extra step before getting to a more useful form like point slope or slope intercept form. So I'm not going to do very much at all with it, but it is worth mentioning. Anyway, let's actually get an example here with the stuff that I think is a bit worthwhile. So for this, we want to graph the linear function f of x equals 3/5 x plus 1. Now the way we can start when we're given the slope-intercept form like this is by graphing the intercept, which, because b is equal to 1, is at the point 0, 1. Then we can express the slope as a fraction using that rise over run to get another point, where because it is 3/5, that means we are going 5 to the right and 3 up. So we're going from the point 0, 1 to 5, 4, for example, or we could go down if we want to, but it's easier to go in the direction as presented by the slope. So that would give us something a bit more like this in terms of how we're moving. And then finally, if we want to fill in our blanks there, if we want to actually get the line, you just straight edge your way through them, and you will have your line running through that point with all of the values like so. It's pretty straightforward. It's something you probably should have experience from dating back to middle school, but even if you don't, it's really not that complex. It's a line with special properties. And before we get a bit of an application here for how we can use this stuff, we're going to get one quick detour into our most basic kinds of lines, horizontal and vertical lines. That is, ones with very special slopes as opposed to our specific values here of m.